Hi class. Well, we talked about the basic counting law in the last video, but sometimes that's just not going to work or it's going to take way too long to do it. So I wanted to introduce two different ways that you can calculate the number of ways: combination and permutation. Now the difference between these two is if order matters or it doesn't. So for permutation, arrangements of a group of items where the order of the items matter. For combination, the arrangement of the group of items except for the order of the objects does not matter. So I've got two tables down here, and let's talk about it. So example, we have 4 students in a group: Abby, Betty, Carson, and David. We need to form a governing body for this class. We need a president, a vice president, and a treasurer. How many different ways can this happen? Well, in this case, the order that the students are chosen matters, because if you get chosen for the first slot, you're going to be president, which is very different in responsibility to the treasurer. So the order that you're chosen makes a difference here. And if you look at this table right here, shows all of the different ways that those 4 individuals can be arranged in a president, vice president, and treasurer role. Order matters. We'll look at the second bullet here. What if we instead needed to form a committee of 3 students for project judges? Committee members have equal ranking. How many ways is this possible? Well, for the second example, the order that you're chosen doesn't matter because you're just part of a committee that has equal ranking. And I've already marked out the repeats. So we have Abby, Betty, Carson here, but we have Abby, Betty, Carson here. It's a committee. It's not a different committee. Those same people are on the same one. We have Abby, Betty, and Carson on this one as well. And these all include David, so they wouldn't be repeating that as well. So what I've done here is I've crossed off all of the repeated committees, and we end up with just 4. So let's take a look at how that looks on an example. So we've got the same problems here. Example 1, we have 4 students in a group: Abby, Betty, Carson, and David. We need to form a governing body for the class. We need a president, vice president, and treasurer. How many different ways can this happen? Again, order makes a difference, so we're going to use permutation. Here's that formula for permutation. And N is the total number, and R is the number you want. So for this first example, we have 4 total people available: Abby, Betty, Carson, and David, and we only need 3 for the positions. So 4 factorial divided by 4 minus 3 factorial. So 4 factorial divided by 1 factorial. This one, guys, we can do by hand. Remember, factorial, 4 times 3 times 2 times 1 divided by 1. 4 times 3 is 12. 12 times 2 is 24. So there are 24 different possibilities of creating a president, vice president, and treasurer from 4 people. Now, if we look back here, we've got 1, 2, 3, 4 in a row, and 1, 2, 3, 4, 5, 6. So that also gives us the 24. But again, guys, we're going to have problems where you just can't make a table and list out all the possibilities. So let's look at example 2. What if we instead needed to form a committee of 3 students for project judges? committee members have equal ranking. So for this one, change colors for you. We've got a combination situation because order doesn't make a difference. But we still have 4 people available. We need 3 slots taken. And so we've got 4 minus 3, and then R, which is 3. So we've got 4 factorial, 1 factorial, and 3 factorial. Doesn't really look like a factorial. We'll do this long ways. 4 times 3 times 2 times 1 divided by 1 times 3 times 2 times 1. 4 factorial divided by 3 factorial. Well, these are going to cancel out, and we're left with 4. So there's 4 ways we can create a group of 3 for a committee out of 4 possibilities. And if we look back here, notice we've got 1, 2, 3, and 4. Now, doing it by hand is just fine. However, if you're looking at a group of 50 people and you need to choose 40, it would be pretty cumbersome. So let's look at the calculator. Let's see here. Now, for permutation, if you go, first thing you have to do for the calculator, which is a little bit different, is you need to type in the first number. This is what it looks like in your calculator. So I'm going to push 4, math, scroll over to probability. There's your NPR, permutation, enter, and then you add that second number, your R number, and we got 24. Same thing's true for the combination. There's your combination. We'll put in the number 3, and we get 4.